Every 11 years, the polarity of the Sun's magnetic field reverses, leading to cyclical peaks in solar activity, and along the same cycle, it aligns with Venus, Earth, and Jupiter. In a new study, researchers in Germany suggest the tidal forces from these three planets may directly influence oscillations in a phenomenon known as the alpha effect, dictating the 22-year cycle of the solar dynamo. While it's known that the dynamo, a combination of the omega and alpha effects, is responsible for the Sun's magnetic field, the origins of the alpha effect have long remained a mystery. In the study, published to the journal Solar Physics, researchers at the Helmholtz Zentrum Dresden-Rosendorf investigated the unanswered questions surrounding the Sun's magnetic field. As with the Earth, we are dealing with a dynamo, explained Dr. Frank Stefani, a physicist from HCDR. Through self-excitation, a magnetic field is created from virtually nothing, whereby the complex movement of the conductive plasma serves as an energy source. The alpha-omega dynamo abides by a cycle in which the polarity of the Sun reverses every 11 years, leading to an increase in dark spots on the surface, known as sunspots. Interestingly, every 11.07 years, the Sun and the planets Venus, the Earth and Jupiter are aligned. Stephanie says, "We asked ourselves, is it a coincidence that the solar cycle corresponds with the cycle of the new conjunction or the opposition of the three planets?" It's widely accepted that the omega effect originates in a region known as the tachocline, where areas of varying rotation converge to generate the toroidal magnetic field. But there is little clarity on the position and cause of the alpha effect, which uses the toroidal field to create a poloidal effect running along the Sun's lines of longitude. Some have suggested that the alpha effect stems from a place near the sunspots, but in the new study, the researchers propose this effect is linked to a phenomenon known as the Taylor instability. The Taylor instability plays a role in the resonance of the solar dynamo and arises when a strong current flows through a conductive liquid or plasma. When strong enough, the interactions between the current and its magnetic field can create a turbulent flow. In the study, the researchers at HCDR found that certain conditions result in oscillations of the alpha effect with just small amounts of energy. The tides of Venus, Earth, and Jupiter may influence the alpha effect based on the principles of resonance. If you only just give a swing small pushes, it will swing higher with time, Stephanie explains. The impulse for this alpha oscillation requires almost no energy. The planetary tides could act as sufficient pace setters for this. The calculations reveal the Taylor instability oscillates between right and left-handedness with little change in the flow energy, suggesting small forces are enough to initiate the oscillation in the alpha effect. Our calculations show that planetary tidal forces act here as minute external pace setters, Stephanie said. The oscillation in the alpha effect, which is triggered approximately every 11 years, could cause a polarity reversal of the solar magnetic field and, ultimately, dictate the 22-year cycle of the solar dynamo.